Assalamu alaikum. Dear students, this class is for 11th subject chemistry and today's topic is buffer solutions and hydrolysis of salts. In the previous lesson, we have studied about the pH of solutions and the pH scale. As you know, there are three regions on the pH scale. One region represents acidic medium, another represents basic medium, and the middle one represents neutral. So, in this lesson, we will look what buffer solutions are. Basically, we know the solutions which have pH less than 7 are acidic and more than 7 are basic, and the value 7 corresponds to a neutral medium. A buffer solution or buffer is a solution whose pH does not change when small amount of an acid or base is added in it. It means that if we add a small amount of an acid or a base to a solution, and if its pH does not change due to the addition of this acid or base, then the solution is termed as a buffer solution. This buffer solution, it is used as a means of keeping pH at a nearly constant value in a wide variety of chemical applications. Many life forms thrive only in a relatively small pH range, so they utilize a buffer solution to maintain a constant pH. So this buffer solution, it finds its applications in maintaining the pH value. In nature, the bicarbonate buffering system is used to regulate the pH of blood. The solution of sodium acetate and acetic acid is an example of effective buffer solution. So, when we add a small amount of acetic acid to a sodium acetate solution, the pH of the solution does not change. So, the solution is termed as a buffer solution. The solution in which buffer solution is accommodated that works like an extremely slow acid. And hydrolysis of salts. As we know, the salts are formed when a reaction is carried between an acid and a base. Salt is a compound formed by the neutralization reaction between an acid and a base. They generally ionize in water, furnishing cations and anions. That means when a salt solution is dissociated, it provides both types of ions. The cations or anions formed during ionization of salt either exist as hydrated ions in aqueous solutions or interact with water to generate the acids and bases. The process of interaction between cations and or anions of salts and water is known as hydrolysis of salts. So, the hydrolysis of salts simply means the interaction between cations or anions of salts and water. When the interaction of ions of a salt solution and water takes place, that is termed as hydrolysis of salts. On the basis of this hydrolysis, salts are divided into three categories: acidic salts, basic salts, and neutral salts. Salts, we will discuss here the hydrolysis of salts of these types. First, we will discuss salts of strong acid and a strong base. When a reaction is carried out between a strong acid and a strong base, how this hydrolysis takes place. Salts formed by the neutralization of strong acid and strong base are neutral in nature, as the bonds in the salt solution will not break. They generally get hydrated but do not hydrolyze. Therefore, such salts are generally known as neutral salts. Example of this neutral salt is sodium chloride, because only the salt gets hydrolyzed, not hydrolysis of the salts takes place. And if we react a weak acid and a strong base, at that time the salt formed by neutralization of weak acid and strong base are basic in nature. So, when a reaction is carried between a salt of weak acid and a strong base, the solution formed is basic in nature. If we take the example of sodium acetate aqueous, that gives acetate ion and sodium. So acetate ion formed undergoes hydrolysis to form acetic acid and hydroxide ions. When this acetate ion it reacts with water, so hydrolysis of this acetate ion takes place. At that time it forms acetic acid and hydroxide ion. Acetic acid is weak acid. It remains unionized in the solution. This results in an increase in concentration of hydroxide ion, which makes the solution alkaline. pH of the solution is greater than 7. That means the solution is basic in nature. Another is salts of strong acid with the weak bases. And the solution at that time formed is acidic in nature when we have a strong acid and a weak base. For example, if we take ammonium chloride gives chloride ions and ammonium ions. Ammonium ion formed undergoes hydrolysis to form ammonia, ammonium hydroxide and hydrogen ions, and the reaction is given. As we know, ammonium hydroxide is a weak base. It remains unionized in the solution. This results in an increase in concentration of hydrogen ions, which makes the solution acidic. Because acids, when we define acids are the substances which provide hydrogen ions. More the concentration of hydrogen, more is the acidic medium. pH of such solutions is less than 7. Another form is salt of weak acid and weak base. At this time, the neutralization of weak acid and weak bases are acidic, basic or neutral, depending on the nature of acids and base involved. So here, when we have a weak acid and weak base, there are three possibilities. Either the solution formed is acidic in nature, or neutral, or basic. It depends upon the substances, acids and bases which are involved in the reaction. For example, ammonium acetate, general mechanism for the hydrolysis of ions formed from these salts. Degree of hydrolysis in such cases is independent of the concentration of solution, and pH of solution is given by pH is equal to 7 plus half pKa minus pKb, where Ka and Kb are the constants. So hence we can say that the pH of solution can be less than 7 or greater than 7 depending upon the value of pK and pKb.